We can also use elimination reactions to synthesize alkynes. In a single elimination reaction, we will get an alkene because only one pi bond is formed. But if we do two consecutive elimination reactions, that will produce two pi bonds that will result in an alkyne. Remember that an alkyne is formed by one sigma bond and two pi bonds. So here we see the mechanism of that happening. Two eliminations would happen back to back, and that will result in the two pi bonds. So here we have the base that will come and take the hydrogen. Remember that hydrogen has to be coplanar to the leaving group, and it has to be in an antiperiplanar position. So this hydrogen is antiperiplanar to this X right here. The base comes, gets the hydrogen, then the electrons collapse, forming the pi bond, and the leaving group leaves at the same time. This would be an E2 reaction, right? Because it happens all in one step. So that first E2 reaction removes the hydrogen and the bromide or the chloride, the halogen in this case. And then we have a second one, right? Another equivalent of base will come, take that H, form another double bond, and the leaving group leaves. So that will give us an alkyne. Here there is another example. So you see here we have X and H and X and H. And here we have HH and XX. It doesn't matter where you have the halide. You can have them vicinal, like in this case, or you can have them geminal. They are hanging both from the same carbon. So in this case, the same thing happens. So the base will come, get the hydrogen, it will collapse, and one of the halogens will leave. Then that's the first one, and then the second one happens again, and that will form the same product. It will be an alkyne. The typical bases that are used for this type of synthesis are stronger bases than usual. So we can use, you've seen this base before, right? You know that that's a strong base because the nitrogen with the negative charge isn't stabilized, so it's ready to go and attack. And this is another base that you've seen before as well. That's terbutoxide. That's potassium terbutoxide, and it looks like this. Sorry, right? So that's no plus. There we go. So that's how potassium terbutoxide would look like. Here there's another example that you can use to practice. So you see here the two chlorines are hanging from the same carbon, and here each of the bromines are in a different carbon. In both cases the result is the same, and we get two eliminations back to back, and you get the alkyne. You can use this to practice, and if you have questions you can come to office hours and we will explain you.